Hello everyone, my name is Sundriyal and I would like to discuss the topic of Young's double slit experiment. Young's double slit experiment was first demonstrated by Sir Young in the year 1802 as an experimental proof of interference of light. Interference of light is actually the phenomena of redistribution of light energy when there is a superimposition of coherent light waves. Okay, so the word coherent should strike in our minds, okay, after reading, after uh, coming about this across this definition. So what is coherent sources? The coherent sources are actually the light sources that have same frequencies, same wavelength, as well as same or constant phase difference. Okay, so what happens actually in the Young's double slit experiment can be summarized in the theory which I've already explained to you. So what we actually do is, there are two things. First, we obtain coherent sources of light, and then we perform the superimposition to get the interference fringes. As simple as that. Okay. Let us go through the experimental setup. Now, experimental setup consists of one slit S and the slit A and slit B. The slit S is illuminated by some monochromatic light source that gives out the spherical wavefront, as S is considered as a point source. Now let us boggle our mind and go back to the Huygens wave principle, which tells us that light has EM wave, and also we can be represented by y is equal to a sine omega t plus phi. That is, it is sinusoidal in nature, consists of crust, roof. Here, the crusts are represented by these dark lines and the roofs are represented by the dotted lines. After the wave front travel and they reach to point A and B, and what we obtain later are the sources of secondary wavefront that are coherent with one another. That is, A and B become the source of secondary wavefront which are coherent with one another. And why they are coherent with one another? Because they are obtained from the same wavefront. Okay. So that is how the first part is completed, that we obtain coherent sources of light. After that, simply the both light waves superimpose, and then there is a redistribution of energy, and in the screen we can obtain distinct bright fringes, dark fringes. That is, and in alternative manner, bright, dark, bright, dark, bright, dark. C, E, F, G are the bright fringes, whereas D and F are the dark fringes. There are many fringes, but because obviously in the board you can have a limited diagram, so this is how it is. Okay, and after that, now let us study the bright fringes as well as the dark fringes. Now in the bright fringes, how we are obtaining it? So actually, the crust of one wave, let's say from A, get superimposed with the crust of wave from B, or the truth of wave from A get superimposed with the truth of wave from B, and then what we obtain is the resultant wave is of enhanced amplitude, and that phenomena is called constructive interference, and we obtain bright fringes. Okay, that is how the constructive interference happens. And the path difference in constructive interference is of n lambda, where that is the integral multiple of wavelength, where n can be 0, 1, 2, 3 or any integral number, and the phase difference is del phi is integral multiple of 2 pi, where n can be again 0, 1, 2, 3. Now we come to destructive interference. So in the case of dark fringes, the crust of wave, let's say from A, gets superimposed with the truth of wave from B. Crust from A gets superimposed with the truth of B, or the vice versa. And then what we obtain is the dark fringe. There is no light there. The path difference here is of 2n minus 1 lambda by 2, and the phase difference is of 2n minus 1 pi, where n is again integer with value 1, 2, 3. Also note that here n. This is very important for the numerical purpose, that here n has a value from 0, 1, 2, 3 and so on, where here n has a value of 1, 2, 3 and so on. If n in the destructive interference also has a value of 0, then again what we obtain are the path difference of the constructive interference. So this is the rough setup of rough idea of Young's double slit experimental setup. And let me also tell you one more point, that interference of light is actually giving us or telling us that light has wave nature. While light has dual nature, wave nature as well as particle nature, interference of light actually gives us the wave nature of light, interference, diffraction, etc. Okay. So I hope I was able to explain the topic well. Thank you so much.